Hello everyone. In this lecture we talk about the magnetic moment of the hydrogen atom. As we know that the hydrogen atom, the electron orbiting in the hydrogen atom is similar to the current loop. Because the current loop has the magnetic dipole moment, it's logical to assume that the orbiting electron must also have the magnetic dipole moment associated with it. As we see in this figure 410A is a current loop and figure 410B is a electron orbiting in the hydrogen atom. And the magnetic dipole moment for the current loop became mu, which is denoted by mu, is equal to IAN, which I is the current in the loop, and A is the area of the loop, and N is the unit vector. The orbiting electron of the figure 410B consists of a current given by I equal to minus E over T, where E is the negative electron charge and T is the time it takes to the electron to go once around its orbit. T is equal to the reciprocal of its frequency nu. Therefore, by substituting the value of the T, which is T equal to 1 over nu, hence equation 450 becomes I equal to minus E nu, where nu is the number of times the electron circles its orbit in 1 second. Therefore, mu sub L is equal to IAN, which is equal also to I minus E nu AN. We substituted the value of I in this equation. Therefore, we get mu sub L is equal to minus E nu AN. Assuming the orbit to be circular, therefore the area A is equal to pi r square, and therefore mu sub L is equal to minus E pi nu r square N. We substituted the value of A in the above equation. Note that mu sub L is the opposite direction in the opposite direction of N because the electron is negative. And we have L, the angular momentum, is equal to R cross P, and R cross P is equal to RP sine theta, which is theta is the angular between R and P. Therefore, L equal to RP sine theta. But P is equal to M sub E multiplied by V. Therefore, we get L equal to R M sub E V sine theta, which is M sub E is the mass of the electron and V is the velocity of the electron. The vector L is opposite to the direction of the orbital magnetic dipole moment mu sub L. But R is perpendicular with on V, therefore the angular between R and V, R and V is equal to 90. Therefore, we can write L is equal to R M sub E V sine 90. But sine 90 is always equal to 1. Therefore, we get L angular momentum is equal to R M sub E multiplied by V. Using the same unit vector N to show the direction perpendicular to the orbit in figure 410A, we can express the angular momentum of the orbiting electron as L is equal to M sub E R V N. But the speed of the electron in its orbit is just the distance S it travels along its arc divided by the time, that is, we get V is equal to S over T, but S is the circumference of the circle, therefore we get V is equal to 2 pi R over T and equal to 2 pi nu R by substituting the value of T, which is a reciprocal of the nu. Therefore, by substituting this into equation 453, we get L equal to m sub e r 2 pi r nu multiplied by n. And this, by rearranging this equation, we get L is equal to 2 pi m sub e nu r squared n. Dividing equation 454 by 2m sub e, we get L over 2m sub e is equal to pi nu r squared n. Rewriting to equation, to equation 452 and dividing by e, we get minus mu L over e is equal to pi mu r squared n. Comparing the right hand side this of equation 455 and 456, we see that they are identical and can therefore be equated to each other, and therefore we get minus mu sub L over e is equal to L over 2m sub e. Solving for m sub L, we have mu sub L is equal to minus e over 2 m sub e multiplied by L. Equation 457 is the orbital magnetic dipole moment of the electron in the hydrogen atom. Hence, mu sub L is equal to minus e over 2m m sub e multiplied by L, but L is equal to root square over L multiplied by L plus 1 h bar. Therefore, we get mu sub L is equal to minus e h bar over 2m multiplied by root square of L multiplied by L plus 1. The quantity E over 2m m sub e is called gyromagnetic ratio, but the quantity h bar over 2m m sub e is considered to be the smallest unit of the magnetism, that is an atomic magnet, and it's called the Bohr magneton, and its value is equal to Eh bar over 2m sub e is equal to 9.274 multiplied by 10 to power minus 24 ampere meter square, and it's also equal to 9.274 multiplied by 10 to power minus 24 joule over Tesla. We have an example about orbital magnetic dipole moment. Say that find the orbital magnetic dipole moment of an electron in the hydrogen atom when it is in state A, S state, and in B in a P state, and C in a D state. The magnitude of the mu sub L found from equation 458, which say that mu sub L is equal to E h bar over 2m multiplied by root square of L plus 1. For A state, we have L equal to 0. Orbital quantum number L is equal to 0. By substituting this value in above equation, we get that mu sub L is equal to 0 also. Therefore, for S state, we do not have any magnetic dipole moment. B, for P state, L equal orbital quantum number L equal to 1. Therefore, by substituting this value in above equation, mu sub L is equal to 9.27 multiplied by 10 to power minus 24 root square of 2 joule over Tesla, and it's equal to 1.31 multiplied by 10 to power minus 23 joule over Tesla. For a D state, we have a orbital quantum number L equal to 2. We get mu sub L is equal to 2.26 multiplied by 10 to power minus 23 joule over Tesla. And thank you.